Find the angle alpha for the given triangle if a side A is 20, side B is 25, and side C is 18. So we know we have a non-right triangle, or at least we think it's not a right triangle. I'm just going to go ahead and use ABC instead of alpha, beta, gamma. So we know that this is side A. Oops. This one is side A. They said it's 20. Across from B is 25. And across from C is 18. So we do have a side, side, side triangle. So we're going to go back to our formulas. We could use these formulas at the bottom, but that's just more formulas that you have to remember. If you could just remember one of these, and you know it's the square of the two sides and the cosine of the angle between them, of course you have the minus 2bc in there. But if you remember that information for one of these, you can apply it to all of your triangles. Okay, so let's see what we have for this one. We want to know angle alpha. Well, I guess I should have used alpha. Sorry about that. Alpha, beta, and this is going to be our gamma. Okay, so we're looking for this angle right here. If you want to refer to your formulas, we're looking for angle alpha, which means we need to use that first formula. So I'll write it down over here for us. A squared is equal to b squared plus c squared minus 2bc cosine alpha. Alright, so we know A. This is our A, this is our B, this is our C. So now we just have to work all these numbers out. So 20 squared is 400, 25 squared is 625, 18 squared is 324. Then you have 2 times 25 times 18. That's going to be 900. Okay, let's go ahead and combine these like terms. So we're trying to get alpha by itself. 900 is multiplied by this cosine. So what we need to do is subtract the 949 first. That will give us negative 549 is equal to negative 900 cosine of alpha. Divide both sides by negative 900 and we get cosine of alpha is equal to 549 over 900. Remember, to solve for alpha, you take the arc cosine or the inverse cosine of both sides. So alpha is equal to inverse cosine of 549 over 900. So we can get an approximation for alpha. We have inverse cosine 549 divided by 900 is approximately 52.4 degrees. So angle alpha is about 52.4 degrees. I know this is hard to read. Hopefully you have your notes printed out and you're looking at them right now. On many cell phones with GPS, an approximate location can be given before the GPS signal is received. This is accomplished through a process called triangulation, which works by using the distances from two known points. Suppose there are two cell phone towers within range of a cell phone. The two towers are located 6,000 feet apart along a straight highway running east to west. The cell phone is north of the highway. Based on the signal delay, it can be determined that the signal is 5,050 feet from the first tower and 2,420 feet from the second tower. Determine the position of the cell phone north and east of the first tower and determine how far it is from the highway. My goodness. Alright, so what do we have going on here? Let's draw a picture. So we have these two towers. I'm just going to use this little signal notation. We have these two towers. Okay? I know that's a weird looking tower, but there you go. And then we have a cell phone. Don't you just love my pictures? Alright, so what else do we know? They said that this is east to west and that the cell phone is north of the highway. So that's why I need to draw the cell phone up here. Let's see what else. The two towers are 6,000 feet apart along a straight highway. So this one is 6,000 feet. The signal is 5,050 feet from the first tower and 2,040 feet from the second tower. So what are we looking for? Determine the position of the cell phone north and east of the first tower and determine how far it is from the highway. So we will want to know how far north and east this phone is from the first tower. We also want to know how far it is from the highway. So we pretty much answer one of our previous questions if we answer this one. So how in the world do we determine all of this? Well, let's say since we're looking for information from the first tower, let's call this angle alpha. That sound good? In that case, we can use the same formula that we used in our last one. A squared equals b squared plus c squared. This one right here. Alright, so we have, if this is A, or alpha, then this is side A. Let's just call this side, or angle B, beta. And we'll call this angle gamma. So that means this is side C, and this is side B. If it helps you to label them, go right ahead and do that. Okay, so what do we have? We have a squared is equal to b squared plus c squared minus 2bc multiplied by cosine of alpha. Those are a lot of big numbers. Okay, so I'm going to, I was going to say I was going to pause the video, but I can't do that with this program. I'm going to go ahead and add this. So we have 615,025,00 minus 606,123,45. Okay, so we need to subtract this number on both sides. We get negative 573,409,00. Divide both sides by this 6 number over here. So cosine of alpha is equal to approximately 0.946 on a whole bunch of numbers. I am going to take that and store it in x for now. That way I don't lose it. So I've stored cosine alpha in that. So how do we find alpha then? is the inverse cosine of our x that we just used. Okay, so alpha is approximately 18.9 degrees.